topic of my today's talk is on meteors and meteorites and what are the present trends in observing meteorites. So you may find a lot of uh, short forms. XRD is X-ray diffraction. Then SEM is normal SEM, that is secondary electron microscope. And EPMA is electron, that is also a similar form of SEM, but there you are able to get better elemental resolutions. And INA and PGNA, it's known as instrumental neutron activation analysis. And PGNA is prompt gamma neutron activation analysis. So basically this kind of work, and the people who are helping me in this kind of work are from IIT Powai. And IIT Powai, that person's name is Shilpa Netrawali. And they have you anyone seen how you see through the electron microscope a meteorite? Here you get a very high resolution. It's around 100,000 times better than your microscope also. So you are actually able to pierce within the meteorite. And then basically in SEM what they do is they have electron beams going and hitting the source. And then you get a very high magnified view of that same meteorite and how it has been formed. As earlier experts have told that when you get a meteorite down, there are two components. The head part of it is completely burned. You remember Kalpana Chawla's space shuttle, when it came down, the whole thing got fire. So even meteors, when they come down, because of atmosphere, they start burning. And the burning is only at the peripheral level. That means at the head level. And behind the head, there is not much damage to the meteor. So what one tends to do is try to take a small chip off and then try to look in. And nowadays, in all these observations, what we do with SEM and all, we tend to find out the basic morphology of the sample which has come to you. And there it tells you how it is. Can we go to the next slide? Huh? Hey. Oh, I'm not talking. ये लगा देना हाँ स्लाइड शो में छोड़ देना अभी उसको चेंज मत कर हाँ ओके कहाँ से यहाँ से ओके now here what you see here about over in this image, it is a very faint meteor, very faint. Over here you see that very faint meteor which is there. So this is what you see in the sky. Normally with naked eye, you can see a very big meteor, which means it may be brighter than even our Jupiter. So that bright also you get meteors. You get very faint meteors. And normally number of faint meteors is more. And then later on I will tell you how to look for radio meteors. So in this, we normally try to see the whole sky. And let me tell you, I'm talking of 25, 30 years back. People used to come to us at Wangni and Badlapur, they used to come and we used to show them how to identify meteors. And we used to make a group of four. So one person will look at cardinal points, one will be looking at north, one will be looking at south. Like that, we used to make a group of four. And then all of them used to have star charts. The stars that you see up in the sky, the same star charts, you have to only pencil mark those to identify the constellation. And then when the meteor comes out of one particular nearby, we used to start plotting it from there to there. This was a program for school children. But you do need a sky chart. And the sky chart should be for that day. If it is in November, if you are going to November 14, is a Leonid meteor. So you will be looking at Leo and nearby stars of Leo. So this was what we used to do visually. And our people also got recommendation, or rather their observation was accepted by International Meteor Organization, which is called as IM. And they used to certify them as a code observer. So they used to give a code number to that observer. So that even today one can do it. It's not difficult. All you need is a good eyesight and a star chart. And nothing more than, you don't even need a camera. But the sight is so exciting that you can identify the meteor also, whether it is bluish white, yellow white, or what. So the color, we had to write that also. So that was very important for visual observation. Now, over a period of time, things have changed. So people now try to use fisheye lens and photograph and so on. But I have a very simple solution for you. You don't need any of that. Your simple camera, 50 mm lens camera, is good enough to identify these meteors. And what you have to do is just point to the north and allow the exposure to go on. Meteor doesn't follow the path of the stars. So what happens is it cuts the constellation. So that is how you are able to identify between a star and a meteor. No, this is not an all star. It's a normal DSLR camera with a 50 mm lens. So you point it to the pole star, but then you have to see where is your Leo at that time, if you are observing in Leonid. But nowadays we start observing from January all the way to December, which means Gemini. Okay, so this is the practice which one does it as a DSLR. And these are, I think, we have heard it from morning, what are major groupings and minor groupings. So these are the kind of meteors or meteorites which I'm also going to show you after I finish the lunar meteor. I have brought it. So these are the things. I'm not going to go into this more details because in the morning people have talked about it. So I'm just showing you how they look like. These are chondrites. Now in that, these round things, they are chondrules. And you can see that with not even a microscope. You can see it with your field lens. It is that simple. So for going for any meteor observation or meteorite observation, I will tell you how we do the field recovery. So again, I'm not going to talk much about the type of, see, Martian meteorites are also. It's not just meteorites coming from asteroid belt. There are meteorites coming from the moon also. What happens? A large meteorite comes and hits the moon. Now, moon doesn't have very good, its escape velocity is very low. So those those fragments fly off and reach Earth. So you do get even moon meteorites coming out of moon. So, and then iron meteorites are very simple. All you need is a round magnet, and round magnets nowadays nobody uses. They use those ceramic magnets. They are very powerful. And if you take a horseshoe, the power of the horseshoe is hardly 600 gauss. Whereas the ceramic magnets, they can be there of 8,000 gauss also. So it actually attracts that iron piece onto your magnet. Yeah, yeah. Neodymium and yeah, those magnets I'm talking about. They're very powerful. And we use in any field trips or recovery trips, we use that. Uh, I will show you some very interesting. There are stories. I am not going to tell you too much about physics and all this. You have heard enough. So these are stony meteorites. And again, when you see them, they're very nice. But you cannot use the whole meteorite. For analysis, we need very small quantity. If we take it in milligrams and micrograms. Now, how do you identify meteorite? This is a very important question which all of us have, because anything on the ground is not a meteor. There will be rocks also available, and all of them need not have magnetism. Okay, so in meteorite, what one should look for is basically these are burnt rocks, means meteorites which has come down through the atmosphere, they have been burnt and then they fall in the space which is there. And you can pick it up also and then weigh it. But as Dr. Bhandari earlier said, you should not apply water. And I'll tell you a very interesting thing. Just few years back, there was a meteorite which fell in Kato in Maharashtra, near Nagpur. And the person who recovered it put it in the water. So how do you further go about analyzing that? But we were able to get some samples. We went all the way to look for those and we got some samples. And then I also mentioned some part of it. It was not one meteor which fell. It came down as a fireball and there was sound. So any meteorite or a fireball coming down, you know what is a fireball? A huge, real fireball comes down. And if you are in the evening sky or just after the sunset, you see it like a daytime, afternoon time. That is how we are able to tell you how the fireball was. And that fireball, we give them, like a full sun means afternoon sun is, we look at it as minus 26 and full moon is minus 12. So we can compare that to a full moon. If that brightness is so much, you can compare it to the moon or sun. So this is very simple thing that I am telling you. So a fireball necessarily doesn't come down. It bursts in the atmosphere. And then lot of particles from that spread out. So people who are watching it don't watch. It's like stone falling on your head. So people rush inside and then they protect themselves. But one can observe that. Density, how heavy is it? Now your hand is the best weighing. So you can weigh a meteorite by your hand only. If it is very heavy, your hand will be like that. So you don't even need weighing machines. But now we have kept small weighing machines to measure even the small meter. So it is possible. And small weighing machines you get. So there is no problem on that. One can buy it. And if you need a list, myself and Professor Bandari, we have made a handbook for meteorite hunter. And in that we are given what you should have, what kind of blade you should have. Everything we have, including the magnifying glass, whether it should be 2x or 1x. That also we tell. You can go up to 3x. So you can make your own. In the field, all that is required just near your belt. So you can identify that and whether they are porous. Not all meteorites are porous. Most of them are heavy because either they are chondrites or achondrites. And achondrites are more fragile. If you drop them, they may break. I'm again using the word may break. But still, you cannot be sure of whether it's a meteorite or not unless you have neodymium. Okay, and the content is usually high in nickel and iron. Now, what is so special about nickel and iron? Most of these are magnetic in origin, and hence they have some iron component, they have manganese, they have nickel in its major abundance, what we call it, more number. So that is possible. Yeah. Now, would you like to hear a story of this? I'm telling you now a story. This story happened in September 23rd, 2003. See, we are using Tunguska event and we are calling that International Asteroid Day. But we are not calling where a fireball, why we call Jagannath also, I will tell you. A huge fireball came down. Okay? And what happened? It was so bright, it was around minus 24. It was as bright as the full sun. And the event was happening in the afternoon or evening, 8 o'clock in Bhubaneswar. And let me tell you, that sound which the fireball made, people started running indoors. Quite natural. And this was told to us by a rickshaw cycle fellow. He said, when we heard that, we rushed inside a building. The sound was so much, they were fearing that something is going to happen. So they ran inside the house and he said, I left my cycle outside only and I went. And this is how most people felt. But what had actually happened was that fireball which came, which burst into atmosphere, fell across some 33,000 square kilometers. So the fireball was not small. It was a huge fireball and it broke into pieces and fell into so many places. And then, as we are aware of literature, somebody saw it from the airplane and he said it is Kendrapada. Kendrapada in Odisha. Yeah, it is near the seaside and it's a virtual place where every year you get a cyclone or a storm or something. Am I right? So that place is filled with a lot of moisture. And when this happened, you see the picture of the above picture is of the meteor which fell down. It fell like a screw, drilling a hole all the way nearly 2 feet. All meteorites have anything from 21 uh, percent to 25% is the iron content. So you can see a full list of all the elements down here. And this, we did not have a sample to correct. See, when you have a new sample falling or a meteorite falling, you don't have anything around it. How does a meteorite look like? What is the iron content? What is the nickel content? So one has to look in the literature for other meteorites and then compare. So this is how we were able to compare it, and we got a fairly big piece, 535 grams, which was fairly large. But that we had to use it for analysis. And there we use instrumental neutron activation. And you know where it was done? Right here in Bombay only. We never went out for analysis. We did it at EARC Apsara. And this got published in Current Science. So hence we say when a meteorite shower falls over a 33,000 square kilometer, how can you call one name, place of one area? If something falls here in Worli, I cannot call a whole area, whole Bombay as Worli, isn't it? So me and my team were, I'll tell you, my team is always of schools, college students and citizen science. And they do the best of the job. So they were able to get the sample, which was very, very important. So this is how we went to see Jagannath meteor, right? And I think I will show you some pictures where it went, that fireball went across a hut. I'll show you. Hut, H-U-T. No. Then what did we see in this meteorite was iridium. Our analysis using INA, we were able to see iridium. Have you heard this name? Iridium? They are called as rare earth elements. So we were able to see iridium, platinum, gold. So in a meteorite, you have all this. It's not I who can do that. Only it is coming from out and we are looking at the composition. So later on we tried further analyzing and then we found that what earlier person Gopalan had talked about how the dinosaurs could be killed. In that he showed that path where Alvarez and his students found a black belt between the two sedimentary layers. And that is what is called as KT for the KT impact. in which it is believed most dinosaurs died. In India, were there any dinosaurs? Not the ones now sitting in the park. I'm talking of real dinosaurs which are in Nehru Science Center. Are there? Outside you see, no? They are models. But such dinosaurs were there even in India. You know where? Can you guess? In India, where were the dinosaurs? Kache. Where is it? Even in your Kutch it is there. Near Narmada. Narmada Valley was actually where dinosaurs used to come and lay their eggs. So now, as a part of this program, we are having a program happening right into Maharashtra in Chandrapur, where they are showing the eggs of dinosaurs, the tooth of dinosaurs, which happened right here in Gujarat. And can you tell me why these Bombay High ONGCs are there? Can you make so much oil and gas? Just think about it. I'm just telling you, to make that gas, you know how much plantations have to be compressed. What should be the pressure on them, by which you are able to convert it into oil and gas. And it is not far. How far it is from Bombay? Hardly less than 80 kilometers in the sea. Huh? No, not because of the dinosaur. Because of the green vegetation which got compressed. Otherwise, how do you get oil? How do you get gas? Pardon? See, that plate tectonics is a process of the Earth's evolution. And meteorite hit is a different event. So plate tectonics has nothing to do with meteorite impact. This is meteorite impact. So this is how people started looking for it. Yeah. So what we did in 2005 and 2011, we took group of students from colleges, and the graph that you see in the over there is made by them. And that's how you are able to find the diameter of Lonnar Lake. Not the lake, Lonnar crater. Over here. There were two groups, and the two groups had to see how much is the diameter of Lonnar. And this, they did it by using GPS. And then by triangulation, they were able to get the diameter. So these exercises, when you do it, then you know why you do physics, why do you do mathematics, why do you have to know it. Global positioning satellite. Okay. So using that, we were able to find the diameter to be 1.8 meter, and this is also well understood. So, and it had happened in a basalt rock. The impact was in basalt rock. Yeah, and these are the samples which we got in Lonnar. What you see up, we have compared it with 25 paisa coin. It was available in those days. in 2005, we could get those coins. So we kept those coins there, and then the rocks, what we found there, we had made that. And the shatter cone that you see here down, what other persons were showing is this kind of a shatter. And if you find a shatter cone, then that it is a meteor impact crater. Pardon? That is not meteor. No, they are not meteor. They are impacted, the impact tides they call. And the one which is called as ATB is none other than Ankush Bhaskar. His observations. This stone which he has picked up as tactile. Yeah. This is also, you just don't get on the rocks, you get inside the rocks also. See, crater formation is not only limited to Earth and Moon. It happens for the rocks also. There also, because of these impacts, crater-like formations are formed. And this is for the stishoites and mescalinites. And you will see the scaling also over there. So this is what you can see. Seeing is believing. Is that right? Now, I wouldn't go into so much of details, but it tells you about craters, their temperatures, their pressures, and what kind of pressure. Ankush was telling in the afternoon about what GPA levels you tend to look for. So, if that is the pressure of that meteorite which comes and bangs the ground, and the ground makes a hole, it's not a small energy. It's a very huge energy, and basalts are very strong. And in basalt, when they make that kind of impact, you should see Lonnar. I would strongly recommend all of you to see Lonnar and go down and see all that. You can go with a magnet and pick up micrometeorites. Go to a temple called as Kamalja. And just outside the temple, you will find these micrometeorites by just putting the magnet inside the wall. Micrometeorite. No, no. Yeah, you should see. Seeing is belief. Yeah. Okay, I understood your question. Actually it's your piece. It's your piece. That's what I say. But GSI doesn't allow. Geological Survey of India doesn't allow you to keep that. You know why? Because the rule according to order of British Empire is any such things happening in Indian continent is the property of British Empire. 1890. No, it goes to Calcutta now. It goes to Calcutta. Now they have become our masters. No? Yes. Because of this rule. And nothing. You wouldn't even get to do any work on that. So this, huh? So, pardon? Maybe because we still believe in British Empire. Britishers were very good to us. We were their slaves, na? No, see, unless you tell that to JSI, they will not ask you. Okay. So whatever you get, finders keepers. And here you will see the thermodynamics of that meteorite which comes. Okay. What is the pressure? What is the volume? Everything you can calculate. There is nothing now hidden. Okay. So this is what I have put up. And then the graphs are there for you want to see that. And I'm not going to go into more of that because there is another 2, 3 topics I have to finish. Yeah. Now this is the picture of Lonnar crater taken by a satellite. Now in the satellite, you will see there is water inside this. Okay, Lonnar. And that water is brackish. So you cannot drink. But somewhere here, just away from the lake, if you dig a hole, you get a water which is drinkable. Now, how it happens, I don't know. But yes, you do get water next to the lake which is drinkable. And the upper picture that you see is the elements in that. What all elements are there in that crater is shown here. Huh? No, no, it's crater, not a water. Water you will, there are papers on that, they find bacteria and not bacteria itself, some form of algae or something, they have found that. I wish the present ones are new form of life. Not found in normal labs. Over there, since the environment is brackish water, so there are different organisms. And 2 years back, I was told that lake also became pink. You are told. Yeah. So it happens to various lakes, not only here. It happens outside India also. There is nothing strange about it. It happens. Ah. Now this is Barringer crater. Now even in India, we show Barringer crater, but not Lonnar, because Lonnar is in Maharashtra. No? Lonnar is in Maharashtra. So why we should show it in other states? But I strongly suggest whether you show Lonnar or anything, it is India. And this Barringer crater, uh, Ankush did explain you about the rim and the center. Now what happens at the center where it gets hit, there is a small hill-like structure below that. And why it happens? Please see the papers. Beautiful explanation of how it impacts, how that becomes circular, why there are rims. Unfortunately, in Lonnar, we could not scale those rims, mainly because uh, it was beyond our budget, honestly. Budget, because you have to do some rope walking or rope sliding and all that, which was not very safe. So we did not venture into that. But yes, one can do that and look for meteorites. It's It's not a closed book. One can go there and observe. But if you are an Indian, you will have to go there and people will start crowding on you. Buy this book, buy that book. Yeah. So it is becoming slightly commercial. That is what I felt. But what I strongly suggest as a International Asteroid Day, all of us should make a venture to make that as a secured place of impact crater. Not because it is in Maharashtra, it is in India, it should be protected as an impact crater. And it is the third largest impact crater in the world. Hence, it needs to be protected. This is protected. It is a private property. The whole crater is a private property. Yeah. Huh? Huh. Yeah. Now, these are other craters in different parts of the world and tsunamis. You heard more tsunamis from Mandari sir. Now, tsunamis are what one saw in South India was a small version of tsunami. This is a mega version of tsunami. Again, we tend to be Victorian horses. What we do is we don't see a fact. One should look at two such craters if I have read the paper, which is called as a Shiva crater. Which Sab? Narendra Bhai? There is one next to Kutch, which is called as a Shiva crater. There is one crater in Bay of Bengal. And Kaveri falls within that. So whether Chicxulub or these two craters are of the same. I'm just provoking you to think harder. Yeah, here also you will see that same shatter cone. And this one is from India only. That this shatter cone is from, I think, yeah, it is from India. And these are meteortectites. You know, he was referring to glass-like features. You can see it here. And that's mainly because of silicon and the temperature. So even silicon melts. Huh? Yeah. Now I won't go into more of details of this glass, diplectic glass and so on, but I will definitely like to show you something more. Now I come to the field work. Even today, there is a very strong need for people to go and analyze water. We have done the diameter, all right, but there is more things which come out of it. And I remember one paper of Professor Bhandari, which he wrote in somewhere in 60s, 64, 65, where he has actually shown the areas where these glassy tektites or glassy materials can be. That paper is an excellent paper which tells you the whole geochemical part of that. Okay. Okay.